Good afternoon, everybody. We're just going to have a brief overview of the usage of the DCM305E leakage clamp, give you a few ideas of how you can use it and other uses that perhaps you may not be so aware of that you can actually do with it. So you can see there we're going to look at intermittent tripping, some fault tracing, natural earth leakage, and as I said before, the other uses and other features. So for intermittent tripping problems, if we look at a normal domestic situation where the RCD is tripping off 2 or 3 times a week and there's no rhyme or reason, or nobody can tie it down as to why it's actually tripping, you can use your leakage clamp to tie that down even when it's not tripping. So you start by putting it around your meter tails. You're then reading the differential current exactly the same as the RCD would do. Depending on what reading you get will tell you what you're actually looking for. So if the reading is fluctuating all over the place, you've actually got a fault. If it's a fixed reading, and generally that will be quite a high reading, it would be too much natural leakage. In other words, too many electronics on the system. To find out which circuit the problem's on, so let's say it's a fault and the reading's jumping about all over the place, the simplest way, turn all the breakers off, turn them back on one at a time, and when you get to the circuit with the fault on it, that reading will then start jumping about all over the place. If it is electronics, as in EMCs, which is the normal problem, you may get a combination over several circuits, but unless you're really unlucky, if it's a fault, it will just be on the one circuit. So once you've found which circuit it's on, so any radial, for example, a lighting circuit, go to the midpoint on the circuit, because this will only indicate what's happening on down line. And if you go on the outgoing pair at that point, if the reading's still there, the fault must be further down the circuit. If it's clear at that point, then it's between there and the consumer unit. And then just keep working your way back or forward, whichever way it's going, and you'll then get to the point where the fault is. If it's a ring main, I always recommend splitting the ring, which then creates 2 radials. Once you find out which leg it's on, do exactly the same thing. Go to the midpoint, test it there. Again, if it's showing, it's further down the line. If it's clear, it's back towards the consumer unit. So you can gradually break it down and work out where the fault is. Natural earth leakage. Generally speaking, we think of this as being EMC, the electromagnetic compatibility on electronic equipment will have a natural leakage that if you have too much of it will trip the RCD. Unfortunately, you cannot do anything about this. It is natural earth leakage. It's the way that it works. Now, what it might well be that you've got 10 items, all with 2.5 milliamps on each on one RCD. So you've got 25 milliamps and it will trip that RCD. You can't change that value. What you'd have to do is split it across several different RCDs, or indeed put in an RCBO board. And please don't forget class 2 items, double insulated, because they can still have a differential leakage, especially if they're connected up by data links between perhaps a TV and a DVD player or something like that. So the combined value will be enough to trip the RCD, but not enough to be doing it unless you get a surge in the voltage or something like that, hence the intermittent nature. Commercially, you may well find that with computers in an office or somewhere like that, you put 10 computers on 2.5 milliamps each, it trips. In that particular case, you've got to segregate it down to several different circuits. We've come to a new regulation in a minute where you can only have 9 milliamps on an RCD or an RCBO. If you've got 2.5 on each, you can only put 3 on one circuit. So it's pushing you towards better controls. There is that regulation 53132. It was brought in the latest regulations because of this problem with the electronics. Part 2 of it actually states, in order to avoid unwanted tripping by protective conductor currents and or earth leakage currents, the accumulation of such currents downstream of the RCD shall be not more than 30% of the rated residual operating current. It's a bit of a mouthful, but if you've got a 30 milliamp RCD, you can only have 9 milliamps of leakage in normal circumstances on that circuit. It's another thing to think of when you're designing your circuits. You take a typical 3-bedroom house now, a lot of people would still put in a ring main upstairs. But if you've got electronics in every room, you know, children with their Xboxes or whatever it is they play with these days, and the parents with a TV and DVD player or whatever it might be, you can very soon be in excess of that 9 milliamps. So it does take a lot more thought at the design stage. Obviously, once you've got it done with the clamp meter, you can check exactly what you have got on there to make sure you're not in excess. Again, with different appliances, how do you read it? Make yourself up a little breakout lead. The picture may not be that clear, but it's just a normal piece of flex with the earth pulled out as a loop. You then put a socket onto it, plug the plug into your socket, plug the appliance into the socket on the lead, and then go in the breakout so you're just reading around line and neutral again. I personally recommend doing it with a twin socket on the end of the little lead, so that if you're doing things like commercial work with computers and monitors, you can plug them both in and do it as a whole, so you get a whole reading for that unit when it's working. Once you know all your individual values, you can then work out how you can redistribute things across different circuits. But again, without the tester, you wouldn't know what values you were looking at. So other uses. You're going to do a board change. 2 o'clock in the afternoon and you think, nice simple one, I'll give it a go. Just stick this round the tails before you start. If you've got a fluctuating reading at all or a high fixed reading, you know there may be some problems. So make sure you start it at first thing in the morning rather than risking doing it in the afternoon and then being there all evening trying to sort out your tripping problems. When you go round to quote, if you're quoting for jobs, what you've got is a simple solution. Quickly stick it round when you go to quote, have a look at it, and it will decide what sort of board you can fit, whether it be a twin RCD or indeed RCBOs. There's an awful lot that this will tell you in one quick test, that no matter how many EICRs or anything else you do, it won't pick up on things like the natural earth leakage. Again, you can use it for 3-phase. So if you've got a 3-phase installation, put it around all 4 tails, so the 3 lines and the neutral. It will give you the overall leakage on that particular installation, and then you can break it down into the individual circuits going away from the board. And if you've got little workshops with, you know, drills and things like that on commando plugs and sockets, the lead I showed you earlier with the 13 amp, you can make up commando plugs and socket leads to do exactly the same thing. Just hoik the earth out and then just read around the 4 cables. If it's a 3-phase only supply, you just go around the 3 phases. Other uses can be used as a normal clamp meter as well, up to 100 amps. So if you want to know what something takes a particular load, just go around the line cable, feeding it, and it will tell you the load. It works on the neutral as well for the neutral current. It's got a function on it that's called wide. It's actually a harmonic filter, and this is one that's coming a lot of interest with it. If you've got things like LED lighting with their EMC protection and lots of electronics going on, they tend to produce a lot of harmonics. You then start trying to dim them and you find out that you're getting flickering lights. Now, it may well be you've checked all your loadings, you've got, say, I don't know, 8-watt fittings, and there's 8 of them, so you think you've got 64 watts. You buy a dimmer that says it will do 100 watts. You put it on and it flickers. And you think, well, how can that be? I've got the right dimmer, but it's saying that it's overloaded. What it may well be, depending on the fittings you're using, that you've got twice as much current on the circuit because of harmonics. And it depends on the type of dimmer as to whether it actually, and I'll use the word loosely, sees the harmonics. And it could be that there's double the amount of current. So if there's double the current, there's double the power. So instead of the dimmer thinking there's 64 watts, there's 128 watts. And if it was a 100-watt dimmer, you're then overloading it and it starts to flicker. You may then put in a different make of dimmer that uses all electronics that won't see the harmonics, and you get no problem. And sometimes it's a lot easier just to stick a clamp meter on there, check out what's going through, take the filter off. So you press the wide function to put the filter on, and it will say 2 amps, take the filter off, it's 4 amps, for example. You know you've got twice the amount of current on there because of the harmonics. A lot of main cables in streets and that are burning out because of the neutral harmonics, where you get out of balance three phases, and with all the electronics again you could have this problem with the high neutral current. And again, up to 100 amp you can put the clamp round the meter, round the neutral, and it will show you the harmonics by turning it on and off. Other features: it's got an automatic backlight, so if you're working in an awkward dark position, the light will come on automatically. You haven't got to press a switch and try and find where it is. Display hold: you've got various options. Most clamp meters come with a normal hold, so you press the button and it just holds the reading, but it's also got an auto data hold. Now what this does, you put it on there, put it onto auto, and if the reading changes, so if it increases or decreases, it will set the little bleeper off inside to make you aware that there's changes going on. It's also got a peak hold. Now that's really handy if you're trying to work out what the maximum load going through a particular cable is. If you turn it's got an auto power off function. If you turn that off so that you can leave it on permanently, you could leave it on a property overnight, for example, to see what load is the maximum draw. It's not a data logger, but it does allow you to see the maximum load drawn. So if you've got somebody that's clicking in an immersion heater but says they're not, and you suddenly look and you've got 16 amps flowing at some point, you'll think, yeah, they must have switched something higher on at that particular time. So it just gives you that option to put it onto peak. It samples 5 times a second, so it will give you an indication of inrush current, but you may need to do it several times to guarantee you get the highest value. It's got an auto ranging function, but you can also set the ranges should you require. So if there's a specific amount where you know you're going to be drawing, rather than waiting for the auto ranging to click in, you can set it on the specific range and it's there and waiting. It's also got a compare feature. So if you've got a bunch of cables and you want to know which one, perhaps 25 1.5 singles coming out the end of a lighting control system, if you know the current going through it and it exceeds the values 0.25, 0.5 or 3.5 milliamps, all you need to do is clip the tester around the cable. You don't have to look for a reading. If it exceeds those values, it will give a bleep. So it just lets you know where it is. And it's just a quick way of trying to find a particular cable.